Charging infrastructure should be designed so that everyone can start the day with a full charge. It is easy to overestimate how much power is required to charge an EV, and it's also easy to fall into that petrol habit of thinking you need to charge as fast as possible. Most of us want the energy we need at the time we need it at the lowest possible price. And the way to do this is to charge as slow as possible with all the cars plugged in, making use of what available power is available when it's available. The faster you charge with electricity, the more you will be charged in dollars to pay for it. A building does not need to have a water supply that assumes every tap is turned on full all of the time. And for the same reasons, nor should the electricity supply be designed to assume all EV chargers are working at full capacity all of the time. Kilowatts, amps, kilowatt hours and kVAs is many new terms that don't really mean much for most of us. Imagine if the temperature dial on an oven instead displayed the kilowatts, and the cookbook might say to cook at 120 degrees, and somehow we have to convert this to kilowatts to set the temperature, and then it makes things a lot harder than they need to be. I know I'd end up with an oven that's way overpowered and my muffins would be burnt. It's the same reason we end up with charging infrastructure, oversized and over budget. There's just got to be an easier way. We need to start using a term that is easy to understand and makes it easier to work out what is actually required from our charging infrastructure. Range adding capacity. This is the potential range adding capacity of an installation over a 10-hour charge session, assuming all cars are plugged in. And it's based on an EV using an average of 23 kilowatt hours per 100 kilometers. And this is a lot more than most will use around town, but some bigger EV will use this amount on an open road New Zealand highway journey. And it's important to use a number that covers a worst case, but also a number that makes it very easy to translate back into Sparky speak. And that's once you've worked out what you actually require. Let's use this car park as an example with 40 EVs that require charging. If we use that Sparky speak, we would require an electrical engineer to work out how many kilowatts translates into the charge time for every different vehicle. And it would all get too hard with plenty of confusion, and then either the wrong infrastructure is installed or the project goes nowhere and the people can't actually charge their cars. So what if instead we look at the range adding capacity required? Do you think that 40,000 kilometres of range adding capacity across those 40 cars is required? What about 20,000 k's, 13.5 or 4,000 kilometres? I don't know who parks in your car park or for how long, but I can guess that around 100 kilometres per day would be well more than what is actually needed. And remember, it's an average, and that the charging infrastructure will power share to ensure the available power where it goes where it's needed. Note that the average daily use for a car in New Zealand is less than 30 kilometres. So if you're working with an existing supply, I'd recommend not even considering an electrical upgrade unless the potential range adding capacity works out to be less than this. When we compare the range adding capacity with what the kilowatts is required to get there, it's easy to see that the kilowatts required is much less than many would think. AC charging stations should be installed as a controllable maximum of up to 7.4 kilowatts. Controller charging is much more important than the ultimate speed. Heat pumps, ovens, hot water cylinders, and all those things that use a lot of power, but they're not always on. There is plenty of time to charge an EV, so it may as well be done by controlling up and down depending on when these other electrical devices are on. Power sharing, ensuring that cars that are plugged in are getting maximum power when they can, enables a bigger window to get the charging done with a controllable load. The first step is for the people who use the car park and or the people who are going to be paying for the infrastructure to work out the target range adding capacity. The people who use the car park, they can add a lot more value at this point than the EV charging consultant or the electrical contractor. Once you've decided the range adding capacity, it's time to engage with the electrician or the electrical design consultant. This is where this useful rule of thumb is used. 1 amp for 1 hour adds 1 kilometre of range. Let's look how this is used within a car park that has 18 cars, doing a typical day's travel. Note that the 18 charging stations are spread across the three-phase electrical supply, and this creates three separate power-sharing charging networks. This is an example of a typical day where some cars have travelled quite a fair distance and others have gone nowhere. Note that the totals per phase are on the left side of the screen. Then we use that in the calculation. Using the rule of thumb, the kilometres directly translates to amps, and then this is divided by the time on charge to give the average current required to do the charging that day. The electrical current is what dictates the size of wiring, the size of circuit protections, and also the cost for the fixed line charge that makes up a portion of the cost on your power bill. Right-size EV charging infrastructure will ensure that all cars are charged in the morning, and in many cases will avoid the need for costly upgrades. In practice, you're not going to add up every individual car, but just come up with a daily average per car park space that makes sense. And you can use this information for a more detailed result in a Transnet eMobility car park calculator spreadsheet, which works it all out for you. This video shows the basic kit set of parts that can take all this together and create a right-sized piece of charging infrastructure for an apartment complex. We take a three-phase supply, split it into its individual phases. In this case, 100 amps three-phase spreads across those three phases, giving a total of 3,000 kilometers range adding capacity. And then the charging stations are added as and where they're needed straight onto the cable tray. Adding into the power sharing makes for a simple, easy use, expandable power sharing network for charging in an apartment complex. Single phase charging is highly recommended. We have a separate video that goes into a lot more detail comparing single phase and three phase charging, but as we've seen, single phase charging is going to give you plenty of capacity for the individual cars and create a more controllable network of charging infrastructure. For more information on this or anything else EV related, get in touch with the team here at Transnet eMobility.